Hi guys, welcome back to my channel. So today we are going to discuss velocity. As we have discussed earlier that velocity is a vector quantity, so we know it by now. So we can also write velocity like this, v and an arrow over it, and velocity is written as displacement divided by time. Okay, so we can write velocity as displacement divided by time, and we can just write displacement like this. And time is a scalar quantity because it only has magnitude and it do not have any type of direction. So what is a uniform velocity? Same as speed, only it has direction. A body is said to be in uniform velocity if it undergoes equal displacements in equal intervals of time. Since displacement is a vector, equal displacement implies the body is moving along a straight line path. Thus, a body moving with uniform velocity is in motion along a straight line path with a constant speed. Okay, so this is actually uniform velocity. And variable velocity is the same. If a body undergoes unequal displacements in equal intervals of time, then the body is said to possess variable velocity. Let's say an object is moving on a circular path, then the velocity is actually not, the velocity is actually variable. The velocity, maybe the speed can be constant, but the direction is continuously changing. So that is a variable velocity. And for similarly, I can write the instantaneous velocity as we have discussed this earlier. Okay, so you can write. So I'm again going to draw a graph here. But this will be a little bit curved graph. Okay, so again I'm going to draw. So this time I'm not drawing the distance time graph, but this time I'm going to draw the displacement time graph. Okay. So I'm going to draw a curved line like this, okay? And let's just say this as T1 and this as T2. So we are talking about instantaneous velocity here. So this will be displacement, this will be time. And we are just going to like again make the dotted lines. Okay. So this will be x2 minus x1, and this will be t2 minus t1. Okay, so we can write delta t as t2 minus t1, and we can write delta x as x2 minus x1. Okay, so I'm just going to again do the same thing. So the velocity will be f limit of t tends to 0, then delta x by delta t will be dx dt. Okay, so this one is actually instantaneous velocity. Okay, so we have just learned about velocity. So next we are going to learn about something very interesting, that is average velocity. So this is the same. So only the difference is that this time the average velocity is the total displacement. So I'm going to write it like that. VAV is the total displacement divided by total time. Okay, So I've just written it like total displacement by total time. So the only difference here is that the velocity, the average velocity is taking the displacement, but in average speed, we have taken total distance by total time. Okay. So this is very interesting. So you always have to be careful about this, that there is a huge difference between the displacement and distance. You cannot write, you must not write in like average speed, you must not write about like total displacement by total time. It must be total distance by total time. So next we are going to learn about acceleration. So what is actually acceleration? Acceleration is actually defined as the rate of change of velocity. So we can write acceleration like this. We can find a relation of acceleration with velocity and time. That is change in velocity, change in velocity divided by time. Okay. So as we have like defined earlier, this change in velocity means, let's say, so we have to draw a graph again here. So at first I'm going to write it like this. Let's just not draw a graph right now. I'm going to write it like this at first. And now I'm going to tell you why we have taken it as P2 minus P1. So the graph should be like this. So let us draw the graph. And okay, so this will be a straight graph. Okay, so we have drawn a graph that is, and this time we have taken velocity time graph, means the velocity is actually in the y-axis. The velocity, this is the velocity, and this one should be the time. Okay, so I'm just going to write it as V1 and V2. So it will be like this. And again, I am going to draw the dotted lines. I am going to intersect it with the x-axis, velocity and time graph. This is, and here I'm going to write delta t, and this will be delta t. So as we have known earlier, we can write delta v as v2 minus v1 and delta t as v2 minus v1, right? So we have written it like this. So now we can define acceleration as the slope of this inclined line. Okay. So what is slope? So slope is actually defined as y2 minus y1 divided by x2 minus x1, or it can be written as tan theta. So I'm going to define slope in a very like simple manner. So if this is a graph, let's say, and I'm just drawing a graph like this, and this one, so I've drawn a graph, and this is, let's say, x1, this one is x2, this one is, let's say, y1, and this one is y2. Okay, so I can like draw the dotted line like this. Okay, so here it will be x2 minus x1, and here it will be y2 minus y1. So here m, that is known as slope or gradient, we also say it like that, is defined as y2 minus y1 So let's say we take this angle as phi, okay, and we can just write this as 2 minus x1, or we can write m is equals to tan phi. Okay, so this is actually the definition of slope. So we have just like known about what is actually slope. So let us now learn about our acceleration part again. So the acceleration is defined as the change in velocity by time. So the acceleration is actually the slope of this line. Okay, so we can write acceleration like delta v by delta t. Okay, so we have just known about the relation of acceleration. So today up to this, in the next class we'll learn about some more of the components of kinematics. So if you like this video, please like, share, and comment on this video, and please subscribe my channel and click on the bell icon to get notified when I upload a new video. Thank you.